So which one do we think you want me to just do these or what?
We could just probably go through the whole.
Okay, let's just rip. I'll go through and then we'll see. Okay. So with the first one, maybe one of the trickier ones from, probably the trickiest one on here is the first one, right? So you're like, okay, I have the thing that's popping out for me is that I have less number of x's relative to the y's, which means any number of these, for instance, like the 1, could go with that 1, or it could go with the 2, or it could go with that. Any number of those x's could go with any of these y's. At which instance you go, okay, I have an x value with multiple y's, right? So that just means if x were equal to 1, right, then I'd have multiple y values somewhere, right? So then it's not a function, okay? Right. A line, this one you maybe, well, I'll do them out of order maybe. I'll go left to right. A line looks like this. It goes forever in both directions, right? So it's going to pass the vertical line test, right? So it is a function. Okay. And then the next one, your clue is you're looking across here. I'd be drawing vertical lines, right? So I'm going to draw one there, draw one there, draw one here. No points. Oh, boom. I get 2 points there. So it fails the vertical line test when x equals 1. So it's not a function for that reason because of this, right? A circle, same thing, right? I get a whole bunch of different multiple y values for any particular x, so it's not a function. This graph here, if I were to solve for this, y equals, I'd have to get y by itself. It would be the, remember, plus minus root x, which I told you the graph of this looked kind of like this. It's what's called the hook or the root graph. But because of the plus minus up front, you get a positive half, but you also get a negative half. So it's actually like a parabola turned on its side, which fails the test, obviously. Right. So again, not a function, right? This one, a little bit tricky. If I were to draw an XY grid, right? Zero's here, and then I'd get out to 6, right? This right here is a vertical line, right? Because every value, if I drew a vertical line from here to wherever, every value along it is going to have an x value of 6, right? And then obviously a vertical line fails the vertical line test because we get a whole bunch of y values, right? So that's no. Is that very good? Okay. Now, as long as everybody's okay with that, let's go to the next one here. Right, so that was your knowledge on functions, right? What's a function versus a relation, or identifying what a function might be with the vertical line test. This piece here was just meant to test your kind of function notation stuff, right? So I have this function f, and I'm going to input 0 for x, right? So here's my function f of x. When x is 0, I'm going to replace it with 0. I'm going to get an answer. So I'm going to input something, and I'm going to get an output, right? So for this one, when f equals 0, I get 2 times 0 plus 8. Well, 2 times 0 is 0, so my f at 0 is going to equal 8. Do we have any absurd questions? No? That one's okay. Next one, same thing. Literally, function notation is take whatever's inside the brackets, replace x with it. That's the rule, right? So with this one, it's f negative 3 is going to equal to 2 times negative 3 plus 8, which is going to be negative 6 plus 8, which is going to be 2. So f at negative 3 equals negative 2. 2? Just positive 2. Okay? And then the rule still applies. It doesn't matter what's inside the brackets. You just put it in there and do the math on it and spit out something, right? So for this one, f at 2a, right? That's going to equal 2 times 2a plus 8. So it's 4a plus 8. Right? Last one, same thing. F at x plus 4, plug it in. You get 2 times x plus 4 plus 8, which is going to be 2x plus 8 plus 8 from the distribution. I'll draw that. So if I distribute the 2 in to both terms, that's where I get this line from, these two terms here, right? And then I just collect the like terms that are left, right? So the like terms are going to be the 8 and the 8 because they're both numbers.
Would you then simplify?
Yep. So the final answer is going to be 2x plus 16.
Like when you divide it by 2.
Oh, sorry. Yeah, you could do that too. Yeah, sorry. Yep. Good. That's fully simplified. Now, sorry. Go ahead.
If you divided it by 2, would the 2, would it just not be like, oh, never mind.
Okay, so that, like, when we start doing, we're going to get into factoring, so we're going to, like, work with the vertex form and stuff like that. That's where we're headed, which is why we're showing you moving parabolas around. But I can do this with a quadratic function instead, and I can input things for x in a quadratic function. That's where things get a little bit more interesting because now we can start mixing in some factoring skills, right? That's one example of a factoring skill. It's just common factor, right? Just good that we got there. But obviously we can do like complex trinomials and stuff like that too, right? That's where we're kind of headed, okay? This one, okay? For this one, the important part is segregating in your head what's going on. I want to know, like you're kind of reading, what is the y value when x equals 5? So I'm going to go read out on the graph. I'm going to go find 5, which is right here. And then I'm like, okay, what's the value of the graph when x equals 5? Well, stand here and look up. There. It takes on the value of 1, 2.5, let's say. Okay. Okay. Same thing for the next one. You're going to go, oh, okay. I want to know the value of the graph when x equals -1. So I'm going to go find -1 on x. There it is right there. And then I'm going to stand there and look up or down. I don't see anything if I look up and down because I'm standing on the value of the graph, right? So at this one, it's equal to 0, right? Right? Then the last one is flipped your order. So now this one's saying, like, what is x given the value of the graph is 15? Right? So instead of walking along here, instead of walking along the x-axis and looking up or down this time, you're going to go along the graph until you find the value of 15. Right? I didn't want a straight line. Right? I'm going to walk along here until I find the value of 15. Right? When I get there, I'm going to look down. Or sorry. Oh, this isn't a great question. Not a great question. I should have said something else. How about it's very easy to confuse this, right? So why don't we change this question? We'll change it, get rid of the 15. Obviously, this could reach 15, but it's never, like, I'm not going to get there, obviously. Right? So it's like not a great question on my part. So let's say when x equals 4. That's what I meant to put down there. Right? I'm going to walk along the graph, the green piece, until I'm at a height of 4. And then I'm going to look down and say, well, how long did it take me to get there? Does that make sense? Right? So I'm walking along here until I reach a height of 4 meters or something like that. And then you're going to say, okay, how long did it take me to get to 4 meters? 15 seconds or something. Right? Right? Everybody okay with that? That's kind of my fault.
If we said 15 on the original question.
Yeah. Sorry. Okay. You want me to do that one more time? Okay. It's like it's saying it's just flipping with the way you're thinking about it. You're like, what's the x value when the value of the graph is 4, right? It's just flipping in your thought process in your head, right? Okay. Now, next question. This wants to know. So you see here, you're going to replace this whole f of x piece with -2, right? So we're going to go, okay, well, I see f of x right there. It's telling me that the y value is -2, so I'm going to replace it right here. So -2 is equal to 10x plus 8. And it wants to know what x is. So now I can solve for it, right? So -2, I'm just going to take the 8 and move it over to the other side. -2 minus 8 is equal to 10x. -10 is equal to 10x. X equals -1. How would I check that? Plug it into the original. Right? If I take this, x equals 1, and I put it in right there, I should get -2 back out. You know I'm good, right? So you can always check stuff by plugging it back in, making sure that left side equals right side. Okay? And then the last one. Okay? Say, this is just me testing your ability to come up with the domain and range, right? So here, remember I said domain I always kind of do in red, right? And I'm like drawing a box around the graph, if I can. If there's no limit to it, right? I can draw a box if it's kind of, we'll call it finite, right? So the domain here, I can never have anything lower than this value or greater than this one. So my domain has to take on everything that's on the inside, right? Because I can have 2, I can have 1.5, I can have 4, I can have 3.75. I can have everything in between those two bars, which is why I go like this, right? That's x is a part of the real numbers, everything, every decimal value from between those values, such that, and then it's a number less than or equal to x less than or equal to a number, squiggly, and then you fill in where you drew those vertical lines. So what values of x? So at -5 and +5, right? And then to read that, you're going to go x has to be greater than -5, but x has to be less than 5 or equal to, right? And then to do the range, it's the exact same thing. Draw your bars. Again, it's continuous between the bars, so you get to say, okay, the range is going to be everything, every y value, right, between -3 and +3. The trick with this question was it wasn't a circle this time, so it's like not, the radius isn't constant, right? So you got a different range than the domain, because we call it an ellipse, right? Which is how most planets orbit things. ellipses. Okay, last one, same thing. Never going to have any domain values less than -2. So domain it's going to be XER, right, because it's continuous, such that x has to be greater than or equal to -2. And then the range, yeah.
If you wrote that such that -2 is never going to be greater than or equal, like it will never be more than or equal, would that be wrong?
-2 will never be more than the
Like,
graph.
like I wrote it the same way as that, but I wrote it
Yeah.
like backwards.
Backwards. So you're saying like x is less than -2?
No, like I.
Oh,
I
-2.
flipped- Like I put the -2 first and the x after.
Yeah.
But I had the same thing.
Yeah, that's okay.
Okay.
I like, just for
Preferred,
future reference, right? Like if I was reading this like a book,
then it would not make sense.
x is a part of the real numbers such that x has to be greater than or equal to -2. If you write -2 greater than,
Like it's just
it's a little awkward to read, right? I get what you're saying. Probably for the purposes of this quiz, I won't take any marks off, but on the test, maybe. Okay. It's like a book. You gotta make sure in your head it's reading properly, right? So then in the range, we're gonna say y is a part of the real numbers such that it's never gonna go less than -1. So y has to be greater than or equal to -1. Okay. Yeah.
For a question like this, like why didn't you just like, is it because like it's a curve? That's why you didn't just like I plotted the points like we did in question A and said, it's like, are you only supposed to plot the points if it's not connected?
Oh, I see.
would it not continue?
It's continuous, though. That's the thing. So this one's just like, some of this is like, okay, some of this is from 3U, right? Some of this material. So this is the graph of y equals root x, and it's been transformed the same way that we're transforming parabolas now, right? So these 3 points specifically, much like when we plotted parabolas, we had 0, 0, 1, 1, 2, 4, right? You know those 5 points. Those are the 3 points for the hook function. So then if I transform them, those are the 3 that I'm transforming, and I can produce my graphs. But in reality, like this thing's continuous all in between here, because I can take the square root of 3, right, for instance, and get a number. I can also take the square root of 5 and get a number. It's just not nice ones, right? So, but the square root of 2 is also, well, that one's supposed to be 4 because it's been moved around, right? So the square root of 4 would be 2, square root of 1 would be 1, and square root of 0 is 0. So they pick nice numbers that are square rootable for that particular graph. Okay. So that's why they don't write the individual points, because I could pick any value of x. You'd be there all day writing a table of values, right? Is everybody okay? So that's the first 3 lessons, or 3 or 4 lessons, whatever we did, right? Summed up, right? So if you can do that, we might have, I don't know, 12 lessons on the first unit test or something, right? I don't know, 12 to 15. So then you're, I don't know, 25% of the way there, if you understand that.